Hello, everyone. Welcome to our discussion on cybersecurity, the energy and automotive sectors, and how technology is shaping the future of these industries. My name is Justyna Szymańska-Laskowska, and today, along with my esteemed guests, Jürgen Böhm, CIO at 7BC, and Tomasz Gandor, Senior Machine Learning Engineer at Future Processing, we'll debate the role of technology in our evolving world. Jürgen, you recently posted an article about the heat pump sector and the challenges it has recently faced. Could you tell us more about that and the roles that heat pumps play in energy conservation?
Nice to stay here, I will say at the beginning. Thank you for the invitation. And yes, I will talk about heat pump systems. And before I will say, we have nearly three important pillars in the climate discussion. The one pillar is to the efficient use of energy. The second may be the electrification of the business and the households. And the last one is that we use more and more renewable energies or resources to produce energies. And we have in Germany 20 million heating systems and about 2 million heat pump systems. Okay. And with our project we have started in 2022, we are able to reduce the consumption of energy for heat pump systems by 20%.
That's a lot.
That's a lot, yeah. And we also are able to expand it to the other kind of heating system as well. But we have a lot to do with 2 million, so it's also enough for the first project. And heat pump systems play a prominent role in Germany. And but you can do more for these heat pump systems, and that's what we try to do, or what we are doing now with our project.
So when we think of energy, it seems impossible not to mention the use of data. Tomasz, tell us, how is data utilized to optimize the use of energy?
Yes, so I can think of two cases that are worth bringing to our attention. The first one is our customer Tauron Dystrybucja. So energy gets produced, distributed, and then consumed or prosumed. And this is the middle part, and it's quite important. And this is happening in the city of Wrocław. So Tauron is running a pilot project with about 400,000 smart meters at the consumers' sites. And they are gathering data about the consumption into the cloud. And we actually were needed first to do some cost optimizations. And actually we've done a lot more. So the analysis led to, so there is about, I think, 1 terabyte of data per month.
That is also a lot.
Yes. So every month you get to buy a new hard drive, but not in the cloud. So this grows by itself. And we also made possible the detection of energy theft. Yes, so unrightful consumption of energy. Next steps, so Tauron wants to, by about 2028, wants to have 14 million of smart meters. The data is gathered. There are also, of course, questions of privacy and security of this data, but the project is going forward. Second case, ISTA in Germany. I'm not sure it's pronounced this way, or ISTA.
Jürgen can correct us.
ISTA sounds good. I don't know this.
I know it because they're also in Poland and in multiple countries.
ISTA technology.
Yes, okay. And we worked together with ISTA to produce a new portal for reporting the use of energy for managers of real estate. So there are managed buildings, for example, and they report the current energy usage. And by the customer's data, it helped to reduce the, I think the magic 20%.
I think so, yeah.
Was the number.
For bigger buildings? Or for grade?
I think, yes, okay. For multi-flat buildings,
yeah.
Which converts to about 3.7 million tons of CO2.
Mm-hmm. Great number. A great project, what you are telling us. And I think all this know-how you have in your company about that we could use for our project. That's absolutely clear here. So, and congratulations for that project. And I and myself and my household will get a smart meter in 2025. So in Germany, we are not faster to have these smart meters. And
What are the challenges? Why is that the case?
Because they have to go to every house and they have to organize it and they have to spend money for that. And but it's absolutely important to have these smart meters. I think from a kind of quality aspect, only what you can measure, you can change. That's what here is a sentence I heard always as I worked for Daimler 20 years ago.
Okay. Well, that's a very nice quote. So coming back to the heat pump revolution for a second, could you tell us more about that and the challenges, the opportunities connected with the revolution?
Yeah, I will say really a revolution of heating systems. And what we are doing is we gather constantly data out of the heating systems and analyze this data and optimize this data to find other algorithms for these heating systems. That's a very big part because we want to do that for millions of heat pump systems, and therefore we need perhaps to optimize the cloud cost in every time. And okay, next one. Our project follows a very simple strategy. Actuators like pumps and sensors for temperature spit out a lot of data. Mm-hmm. And these actors and sensors come together in a controller, in a heating controller. And what we are doing with this project, we take the data out of the heating controller and use it for optimization of the algorithm for each heating system which is with us connected. Okay, good. So we have this data with us, and if you have this heating system data, you have the data of this house, and you are able to control the whole household. And I will say, everyone heard this sentence before, data, in my opinion, is also the gold of the digital transformation nation. So, okay.
If you know how to use it.
Yes, absolutely.
Yeah, some people say data is the new gold. Some people say data is the new oil because you have to refine it. But
that's a good one.
But I've also heard some opinions to the contrary, because it's a bit different than gold and oil. Mainly because of in case of gold, the defining factor is quantity. Yes.
Okay.
So if you have more, it's better.
Yeah.
With data, the most important thing as an ML engineer, I'd say, is quality.
Mm-hmm. So I do not agree fully.
Okay.
I do not agree fully because the mass of data is very important. And you have to be sure that you are able to find out the quality of this data. So if you have enough data, it's better to push them down to quality. I think it's today to gather data as much as you can. So that's what I hear and what we are doing as well. That is the chance to have an outcome of this data.
Yeah, so that's true that you increase the probability that the data is more representative.
Yeah.
And models more cases of these homes, and also it's never a big problem to delete redundant data if afterwards.
Anything else to add on the heat pump revolution?
Yes, absolutely. But we can do more than only gather data. With this data, we detect errors or faults in the heating system. And the second is the optimization of this heating system. And the third is we can provide predictive maintenance, because we know what is the status of this heating system. And we can say, okay, I think we have a pump that's 20 years old. Try to give me in summer another pump for this heat pump system. That are the main three factors of this system, and the fourth is we can integrate the smart home functionality, smart home closing the window and something like that. And for that, I think you could get another 10 to 20% improvement. Yeah, and that's what we want to do to the end of this year, 24, and at the end of 2030. 100,000. We want to control 100,000 of heating systems. And we want to integrate the cars as an energy storage with a mobility guarantee. We want to support the smart grid partners. And as well, we want to organize, or we want to buy energy at the electricity change for our customers. So that is also a way to save money for our customers. And you have mentioned before the 3.7 million of CO2 reduction. With this 100,000 of heating systems, we could reduce more than 750 million CO2.
Wow. And that's by 2030, you said, right?
By 2030.
By 2030. Yeah. Okay, soon enough.
Okay. Yeah.
So the intersection of AI and electricity holds immense potential for revolutionizing the energy landscape. So Tomek, maybe one more question to you. From your perspective, how do you foresee this synergy transforming the energy sector?
So I think the expansion of this heat pumps and e-mobility, also working together as buffering, has a lot of potential. Smart meters and buying electricity, like day trading, it's necessary to some extent, because sometimes in bad, cost distribution scenarios, the producers, consumers sometimes overload the grid, and then actually, for example, get the electricity back at time of high load and peak usage. Yes, and this is sometimes done by hard regulations. Like I've heard something that in California they said that these are the hours curfew for charging EVs. Yes. During peak times, the chargers should not be employed, and it's done through smart metering systems where they can turn this off remotely. But another method is, instead of hard bans, you can have price incentives. Yes, so it would be cheaper to consume a lot of electricity outside the peak, and in the peak it would be more expensive, and to some extent everybody would be happy. But I am afraid that in such a scenario, the price at the peak could be prohibitive, yes, sometimes. And we don't have yet enough energy storage capacities for every consumer. So there are challenges. But I think we're only going forward and developing other stuff. I'm against destroying the existing infrastructures, like, for example, banning cars in order to replace them with electric ones, because it's a huge upfront investment and burden on the environment. Yes, so we should use sensibly what we have and optimize. The first pillar that you mentioned was sensible and optimal use of all energy sources. Yes, so we should not only conserve electricity, we should conserve wood, and we should conserve petroleum products, and we should conserve mineral coal, something like this. Yes, and I think it's a long process, but it is also necessary because some of these resources are not renewing themselves, so we have to switch at some point in the future to something else.
Final comment from you, Jürgen, on what Tomasz said.
We should switch as fast as possible. In case of our climate story we have now with our Earth, and I think we know that it's possible. The technology is there. We can switch off heat pump systems 100,000 at 2030 and put it on step by step when energy is available and cheap energy is available. All the things we know it is possible. We only have to develop the systems they are able to do that. And it's also not a big problem. It's a kind of we'll say state of the art we should do now. It's something that's necessary, but we have we'll say I don't want to say force all people to do that, but I think it's good that we provide technology and systems that it's possible for everyone to have this technology.
So my final question, the challenges that the heat pump sector faces, what are they?
Nice that you asked me that. Okay. The most challenge is that we need about 10,000 of heat pump systems in our project to get profitability at the beginning. So we have a lot to do before we earn money. And another thing is we have to convince the heating industry to work with us together, because today they earn a lot of money with other heating system like oil, like gas and wood and so on. And I think it seems to be like it is the same situation that we have had with the automobile industry. The automobile industry in the past sell all his old technology. And on the other side, we can see what was the result. Mm-hmm. And the result was named Tesla, was named Chinese industry, was named Indian industry. And that could be the same fault with the heating industry, that they are on the same line as the automobile industry. Maybe it's too late when they want to change to look at this data and earn money out of the heat pump systems, maybe.
So Tomasz, as someone who knows a lot about technology, tell us, how is e-mobility transforming the automotive industry, and what are the key technological advancements driving this transformation?
About technologies, well, you've probably heard a lot about batteries, which I don't think are really... So they're technically now driving, as in providing energy, but the progress is a bit too slow. I've heard something about iron phosphate, something batteries, and I hope they will find this wonder battery, which is 10 times better than lithium ion and so on. They will find this, I hope. But right now it were just clickbaits, and I've never seen this battery, not in my phone or in my laptop. But there are actually, in the case of electric cars, many technologies that need to be a bit different than for internal combustion cars. For example, because of the battery right now, as I said, and the weight of it, the electric cars are generally a bit heavier. And they include active braking with energy recuperation and so on. And this all influences the steering system. And it's more challenging to provide solutions for steering. And one of our customers next year is actually developing such systems to handle all these requirements. And also this steering is, drive-by-wire, so it can be used at some point to introduce autonomous driving, yes? Because it's just signals from the controllers, or it could be a computer. And our job for this customer was not actually connected to designing steering solutions, but optimizing their processes. Solution, which is, I guess, something like a CAM, a computer-aided manufacturing system. And it was paper-based before our project together, and we've achieved some 83% optimizations of. That's
an impressive number.
of some of the steps and the pipeline that from the preparing of the materials to the final distribution of the product. And also we eliminated 100% of paper in their processes.
Yeah, very good project. Wonderful.
So Jürgen, what are the implications of this transformation for consumers and the environment?
Consumers and the environment. I will say, let's talk about the traffic and so on. And I think we have to rethink the mobility. And should not ignore the physics about that. In Germany, we have this no speed, sometimes no speed.
Sometimes.
No speed, sometimes no speed.
Not so much these days.
free driving. Mm-hmm. And what I really know as not as a specialist, but as someone who knows a lot about logistics, is different speeds will lead to traffic jams in the shop floor, on the road, everywhere. If you have these different speeds, it's absolutely clear. It's irregular, and you have always the same things in front of you. You have buffers or you have jams, traffic jams. And what I've learned as a logistic person was one piece has to flow. And that's what we have to transfer on the traffic in the future. And I think we have two possibilities. The first is we have to wait until the cars are able to drive autonomously. And the second is we change the traffic. Perhaps we need a separate line for automotive driving cars and get all this experience, what we need to drive a lot of cars together. It's
platooning.
Platooning.
Mm-hmm.
Because it's not so easy to have every car as a separate unit.
How do we do that?
Traffic engineering is an advanced topic, and it's really being worked on also in the case of humans. I think we can find solutions where we can make these two things work together. Because in the case of moving these vehicles together or reacting together, yes, I think it's a very big problem also here in Poland, that when the green light comes on, people are starting sequentially. And only when one person passes the whole crossing, the other starts, and just 3 cars move past, and the red light goes on. And if they started all at the same time, which sometimes happen, and I see that professional drivers actually do this, yes? Yeah. So sometimes it's good to stand behind 3 trucks, then behind 5 personal vehicles, and they start together. But this goes sometimes in different directions. So we are calling different things differently, and one name is good and great, and the other is bad. For example, one thing is tailgating, yes? So if you drive right behind someone and you get the air resistance removed, this is bad and you'll get a ticket for tailgating because you didn't keep your distance. But this is more ecological, just for the person tailgating. And now we say, okay, but if the cars were autonomous, then it's beneficial for them to stick close together, and they will use.
But they are then less prone to error than human error.
Yep, I think the best driver for connected cars is a machine. Sorry, but the machine isn't drink alcohol, no drugs. So we need a machine to drive a car. We need a machine to drive connected cars. And then you have these, you need an autonomous car. And that should not be a car of you or me or you. It's a kind of, or a part of public traffic. We have to use this autonomous driving car as an public commodity, yes. So not everyone needs a car, but we need this technology that someone will pick it up at home from any car, drives to his workplace, pick up some other persons who have the same direction, and then it's not necessary that we have some trams on rail on the road or something like that. So,
but they're even more efficient, yes.
More.
They don't have these so much friction, the trams, and for very busy routes, you could still put more people through a tram than through a series of autonomous vehicles, even if they drive close and are automatically controlled.
I agree, absolutely. For if you have a lot of people who want to be in one direction, the tram is the best way. The train is the best way. That's absolutely clear. But we have a lot of individual traffic. And this individual traffic, we sometimes try to solve with trams, with large buses, and so on. So in our country, in our town, I lived sometime near the station, and at the morning I saw full buses, and at the evening I saw full buses, and every other time on that day I saw buses with only one person, and that was the driver. 70 tons of a vehicle is driving around with no one who uses this. And we have to split that off to have the useful transportation means for different we'll say use scenarios. Yes, yeah. Thank you. And therefore the autonomous driving car could be a part of the public transportation. So that's what I think about it. So I agree fully what you say, absolutely.
So a bit of a controversial question for me, but connected with what we're talking about. So some people say that the automotive industry will become obsolete in the future. What is your take on that?
Yeah, so first of all, predicting, I don't like the word predict. Yes?
Okay.
I like
although in machine learning, we say that the model predicts something, but a physicist, my uncle says that predicting is hard, especially hard when it comes to the future. And that's, I say we can forecast. This is a better word and more down to earth. because everybody knows how reliable the weather forecast is, but still we all check it almost every day, yes? And I think the transformation will happen, but actually vehicles have already once saved us all, because there were also experts in Paris and people were driving around horse carriages, and the manure was gathering on the streets, and they predicted that there will be some meters of this manure until 1950 or whatever. Yes. And it didn't happen because of the development of the auto industry. And I think that it would be very ungrateful to ditch the car altogether. And it's actually an extension of our first invention, of the wheel. And we shouldn't reinvent the wheel, as the saying goes. And I really agree that public transport can go a long way towards reducing the traffic, because the car, as you see in car advertisements, you see cars driving through the forest and through the mountains and
but
freedom.
Not in the city.
Yes, but not in the city, not in traffic jams in the city. And this is what the real image looks like, yes?
I agree partly. So first of all, I think the weather forecast for the next day is impossible, because we can't know exactly how the weather is tomorrow. Today, we know, okay, at 8 o'clock, raining, perhaps. We have an idea what the weather is the next day. Predict the climate for the next decades is possible. That has a lot to do with likelihood and modeling the Earth and the climate. So I think the prediction is absolutely necessary, and it's possible. I disagree with your opinion there.
Okay.
That's why I also do some predictions, and I like it. And I have another story about London, 1900.
Okay.
In 1900, they have a law should not
go faster than horses.
Than horse-drawn carriages. And these people at that time could not imagine that a street is wider than one lane. They can't imagine that we have 8 lines between the big cities, and 4 to 2 lines everywhere. So I think we have to think more in the future, to think about what is possible. Because my absolutely opinion about that, about that is, this decade we have now is very fast, and we know everything is very, very fast done, very fast developed, like mobile phones and everything you see. And I think the cars also will transform very fast to another vehicle, to a vehicle without a driver. And but I agree with you that people has to have their freedom to drive at the weekend everywhere they want, in the mountains or everywhere, to get some stroll, as you mentioned. But do they need an own car for that weekend?
So, gentlemen, with the advancements in e-mobility and the automotive industry, there's an increasing reliance on digital technologies and connectivity. That brings us to our next important topic, cybersecurity. As our vehicles become more connected, the need for robust cybersecurity measures becomes crucial. Let's explore the importance of cybersecurity in the context of e-mobility and smart energy systems. Jürgen, what's your take on that?
Yeah, I think cybersecurity will become a known industry in the future, or is it now, I will say. And cybersecurity is to digital transformation, what the safety bell or all these safety systems are for a car. I think it's very important. But first, the innovation, the car, and then the security, the safety belt. That's what we have in the past. First, we drove with cars without any safety belt and we find out, okay, we need a lot of things. Otherwise, the car wasn't developed so fast like in the past we see now. And it's important, but we need this cyber security absolutely. And we in our project, we need this absolutely because we have the households data and we have the households within in our project, and we need this security as well.
So you wanted to add one more comment to what you said before?
Yes, about this security. Mm-hmm. That's my principle, what I said before, and that's why I'm here with you here and with future processing, because we need know-how, we need experience about cybersecurity, and we know you have the know-how about this.
Yes. We even have a dedicated team that really does security projects and audits our projects. So not every developer is a cybersecurity specialist, but we have standards in place and procedures. And there is this new regulation, DORA or DORA. which will come into effect January 25th, and it applies to finance, insurance, fund management, and ITC providers, which means future processing, among others. Yes.
There's another one also coming into life on October 18th, NIS2. So a lot of cybersecurity work to be done.
Yes.
So Tomek, final question. What measures are being taken to ensure the security of smart systems?
Following the practices that are set out for cybersecurity, auditing the specifications and changes, monitoring it, and also for the security of such systems, there are layers upon layers of security. Yes. So one thing is network access. If it's in the cloud or on premises, there is always a limitation of network access, and it's then monitored by intrusion detection systems. Then there are authentication and authorization protocols to perform specific transactions in the system. And this is also collected then finally backup strategies and securing the physical infrastructure from any trespassing or disruption, power backup systems and so on. So there is a lot to think about, and also there are many layers, which means that no single incident or failure should really lead to a breach. Also, the system needs to be updated when it comes to the underlying libraries and technologies, operating systems, and so on, to prevent attack vectors. And another thing is limiting exposure. Yes, so the area that can be attacked, which means sometimes rethinking features or limiting the actual functionality to what's the task of the system, instead of adding just anything that comes to mind.
Wonderful. So, gentlemen, any final thoughts on the future of energy, e-mobility, and cybersecurity?
I think all is set. We only have to do it.
Follow the plan.
And we can now wait and see. And those who work in these areas can do their best, so that it's really for the benefit of us all, and not something that gets bad press and people complaining about.
So thank you, Jürgen and Tomek, for sharing your ideas with us today. And thank you for joining our insightful discussion. As we conclude, collaboration and innovation stand as essential keys to progress toward a sustainable future. We will explore these topics further in our future conversations. So let's keep moving forward with technology.
Thank you.
Right. Thank you.